Practice Exam 2, Part 4. We're up to question 7. If we gave indirect proof as the justification for this formula, okay, I'm putting up the page because I want you to see how it looks on your page, right? Although you should have it in front of you. If we gave IP, indirect proof, as the justification for concluding, not brackets A or B, what must have been our assumption for IP? Okay, so you have to think that what that means is the formula they've given you, this one, is, right, if we gave IP as the justification for concluding this, so it's going to come at the end of an IP subproof, right? It's this step after you've discharged the assumption, right? This is the justification here is indirect proof, right? See this assumption. And they're asking you, what would your assumption have to be, right? The first step, which started the subproof, in order for that to be the formula you've derived by IP. Okay, please watch the lecture on Unit 9 and read the chapter for discussion of discharging assumptions, setting up subproofs, so on and so forth. But what this question is asking you is to be clear on how you rigorously apply the form. Okay, so an incorrect answer, all right, is saying not, brackets A or B. That is not correct. It does not fit perfectly, and all the answers have to fit perfectly, the form for indirect proof. So here it is. Here's the form for IP. You assume, so P, again, P, Q, they're sentential variables taking as substitution instances, any formula of whatever complexity, right? You're assuming of the form P, you're deriving any contradiction, anything of the form Q and not Q, which means any formula and its negation. It can be A by conditional B and not, brackets, A by conditional B. That's a perfectly fine contradiction. Whenever you have a formula of that form, a formula and its contradiction explicitly put together in a conjunction, that is what entitles you to end the subproof and infer on the main line. See lectures on Unit 9 for how formulas on the main line are epistemologically superior to things within the subproof, right? These are sort of absolutely true given the proof, or true following the premises. The formulas within the subproof are only true given the assumptions, right? Only true under the assumption, only true under the formula assumed. Okay, but this is the form, right? You assume P, you derive a contradiction Q and not Q, and then you infer on the main line as the conclusion, not P, right? So be clear on the difference between what the form is, assuming P, right? This is the form for indirect proof, assuming P and inferring not P, that is what it is. What it is not P and then P, okay? It's not the case that you start here with a negation and then take away negation. And that's what you would be thinking if you answered this, not, A or B, or if you gave the answer to the question as written as not, A or B. No, you're inferring that, so it's actually, if this is, so you have to think, if this is my not P, right, this is my not P, because it's the conclusion. So what's my P? The answer, right, went a long way around to get the simple answer, which is just that, right? If this is my P, if this is my not P, what's my P? Well, this formula is the negation of this formula, right? So that's what P is, so that's what goes there, and then this is not P, okay? So this question is an example of questions, like questions on the actual exam, which ask you, which test your ability to see whether an application of the rule is rigorously fitting the forms, right? Is a rigorous application of the rule. So compare, I've just put up another one here. Here's a question. Is this a correct application of the rule of contrap, right? So answer the question, pause, welcome back. No, it is not, right? This formula is logically equivalent to a correct, not here, mate. This formula is logically equivalent to a formula you can derive by contrap. But what is the rule of contrap? Look at it again. It's replacement rule, so logical equivalent formulas. P hook Q is logically equivalent to not Q hook not P. Okay, so to perfectly use this rule, you have to either, so you're going to swap them around, you are doing here, but you've got to add a negation to both sides or remove a negation from both sides, okay? You cannot do what you've done here, which is add a negation to one side and remove a negation from the other side, right? So the correct so the answer, if you ask a question like this, a yes/no question, is this a correct application of the rule? You say no. You don't say yeah, because if you just do a double negation, then no. You just say, is this, as stated, a correct application of contract? No. Flat out no. Okay. Correct application of contract gives you what? Not B. Since this doesn't have negation, you'd have to be adding a negation to both sides. So that. And then you could get B hook not A by double negation applied to the sub-formula, that is the antecedent of that conditional. As it is, no. Okay? So look out for questions like that. All right, that was 7A. 7B, I've just given you the answer up here. If we gave conditional proof, that this is the justification for concluding this thing, 7B there, what must have been our assumption for conditional proof? If you know how to do conditional proof, that's very easy, right? You just look at that formula, you ask okay, it's got a bunch of hooks, which one is the major operator? And then what's to the left of that is the antecedent of that conditional, right? So you recognize B as it must be to be a conclusion of a conditional proof. That is a conditional. And the question is just, what's the antecedent of the conditional? That's what you assume in a conditional proof. That's the answer. It's just the A hook, bracket C and B. So that's 7. Okay, and I've got here the answer to 8. Construct a proof from the premise to the conclusion, right? So I hope you all know how to do proofs by now, but again, I haven't seen you since your quiz 3, and some of you didn't know where to go on the most simple of proofs. But that's the kind of question. That's what the question looks like in the exam, right? You're given a formula here. You're just given one premise, right? A formula, dash, triple dot, and then the conclusion. The first thing you have to do is write the conclusion, right, vertical line, list the premises here, all the things before the dash, and leave a bunch of space and write the conclusion down the bottom. Right? You don't need much space, but usually, write a line and the conclusion down the bottom, right? What is a proof? It's a sequence of justified steps in which the last step is the desired conclusion. Okay? So that's what you do, and then sorry, I should have said this is prem. You've got every step has to be a justified step, and a justified step is a premise or an assumption or a step which follows from the other steps according to rules of inference. So that is, even step 1 has to be justified by writing premise or assumption, in this case premise. Okay, and then this proof is simply, right, remember, not this. This is my emoticon for the happy face. Negated disjunction, because whenever you see a negated disjunction or negated conjunction, you should be put in mind of De Morgan's, a very often used rules, which you absolutely have to have mastery of to get anywhere in these proofs. But this is, if you see this amongst your premises, or you derive a formula of this form, negated disjunction, I say that you should put a smile on your face, because you then apply De Morgan's to that, and what do you get? You get a conjunction, right? Negated disjunction becomes a conjunction of negations. These formulas are logically equivalent. It's not the case that either B or T are true. It's the same as two things are true. B is false and T is false. Yes, those are logically equivalent, right? And why was this a smiley face? Because conjunctions mean you can simplify, right? And that's the proof. That's the conclusion you were asked to derive. All right, so that's 8. I'll come back in the next part and start question 9.